Defining functions. In Dart, functions are a set of statements that take inputs, do some specific computation, and may return an output. Functions are defined using the return type function name parameters syntax. This code defines a simple function called sayHello that does not return any value, hence it has void as its return type. It accepts one parameter, a string called name. When called, it prints a greeting to the console. Optional and named parameters. In Dart, functions can have optional parameters, which are not required to be filled when the function is called. There are two kinds of optional parameters, positional and named. Positional optional parameters are listed after required parameters in square brackets, while named optional parameters are surrounded by curly braces. Named parameters improve readability of function calls by explicitly stating the meaning of each argument. The function greet has one required parameter name and two optional named parameters, prefix and suffix. The prefix parameter has a default value of hello. If prefix is not passed when the function is called, it will use the default value. The suffix parameter is optional without a default value, and thus can be null. When calling greet, you can specify named parameters using the parameter name value syntax. You can skip optional parameters, or just pass the required ones. Default parameter values. In Dart, you can specify default values for parameters in a function. This means if a value is not passed for that parameter when calling the function, the default value is used instead. This can be useful for setting sane defaults or creating optional parameters. In this example, the function greet takes two parameters, name and message. The message parameter is enclosed in square brackets, indicating it is optional and has a default value of hi. When greet is called with only the name argument, Alice, the function prints out the default greeting. When called with both arguments, Bob and hello, the function uses the provided message instead of the default. Anonymous functions. In Dart, anonymous functions, also known as lambda functions or closures, are functions that are not named. They are often used for short snippets of code that are passed as arguments, returned from other functions, or used to initialize variables. In the code, list.forEach item, the function item, print item, is an anonymous function that takes a single argument, item. It's being used as the argument for each, which applies the function to each element in the list. For each iteration, it prints the current item, demonstrating the use of anonymous functions for succinct operations on collection elements. Arrow functions. Arrow functions, also known as fat arrow functions, are a concise way to write functions in Dart. They use the equals syntax, which is a shorthand that returns the expression that follows it. These are useful for single expression functions and can make the code cleaner and easier to read. In this code, add is a function that takes two integer parameters a and b and uses an arrow function to return their sum. Operator means that the result of a plus b is automatically returned without the need for the return keyword and curly braces. This syntax is especially handy for inline functions or callback functions. Function as first-class objects. In Dart, functions are first-class objects, meaning that they can be used as values in the same way as other types of objects. This concept allows us to pass functions as arguments to other functions, return them from functions, and assign them to variables. In the provided code, the function add is assigned to a variable named calculate. The calculate variable now holds a reference to the add function and can be invoked like a function itself. When we call calculate 5, 2, it executes the add function with the arguments 5 and 2 and returns the result, which is then printed to the console. Closures. In Dart, closures are a special function type that can capture and access variables in their scope. A closure is a function object that has access to variables in its lexical scope, even when the function is used outside of its original scope. The code defines a function makeAdder that takes an integer addBy and returns a closure. The closure, in this case an anonymous function, captures the addBy variable. When makeAdder is called, it creates a new function instance with a reference to addBy. The main function creates two adder functions, add2 and add4, by passing 2 and 4 respectively to make adder. Even after exiting make adder, when add2 and add4 are called, they remember the value of addby that was present when they were created. Thus, add2 of 3 returns 5 because it adds the captured value 2 to the argument 3, and similarly for add4 3. Lists. In Dart, a list is a collection of items. It is an ordered group of objects that can be accessed by indices. The list can be of a fixed length or can grow dynamically. Lists are similar to arrays in other programming languages, but with more functionality. You can add, remove, or search for items in the list. The code demonstrates the creation of a list named fruits with 3 string elements. It shows how to access the first element using its index, how to add a new element, orange, how to update an existing element by its index, changing banana to kiwi, and how to remove an element, mango. Throughout these operations, the list maintains order and can be manipulated using methods like add, index assignment, and remove. Sets. In Dart, a set is a collection of unique items, which means it cannot contain duplicates. It is unordered, so the items do not have a precise order like in a list. Sets can be very useful when you need to ensure that a collection contains only unique items. They also offer efficient operations to check for the presence of an item, as well as set operations like union, intersection, and difference. The code above demonstrates various operations with a set in Dart. Initially, we declare a set containing some fruits, including apple twice, to show that duplicates are automatically removed. We then verify that apple is in the set, add a new orange, and remove mango. Afterward, we create another set, tropical fruits, and perform an intersection operation with the fruits set to display common elements from both sets. Maps. In Dart, a map is a collection of key-value pairs where each key corresponds to a value. Maps are often used to represent a set of identifications or properties where each key is unique. You can define a map with literal syntax and use it to retrieve, update, or remove items based on their keys. The code demonstrates the creation of a map with the variable capitals, containing some countries and their respective capital cities. The first operation shown is adding a new key-value pair for Italy. The second operation accesses the value associated with Germany, which is Berlin. The third operation updates the value for Norway. Each key in the map is associated with a single value, which can be retrieved or modified using the key as an identifier. Finally, a key-value pair is removed using the remove method, demonstrating that maps are mutable. Collection if, for, and spread. The if statement inside collections allows for conditional inclusion of an element. This can be useful to add an item to a list only if a certain condition is true. Here, the list nav includes sale only if promo-active is true. This is helpful to construct collections based on conditions without having to use imperative code patterns like if statements outside the collection. Iterable and Iterator. In Dart, Iterable is a collection of elements that can be accessed sequentially. It is a base class for many collection types, such as list and set. An iterator is an object that is used to access the elements of an iterable, one by one. In the provided code snippet, we define a list called numbers, then use the where method to create an iterable, even numbers, containing only even numbers from the numbers list. An iterator is then obtained from even numbers using the iterator getter. We iterate over each element in the iterable by continually calling iterator.moveNext, which moves the iterator to the next element until it returns false, indicating no more elements to iterate over. Inside the loop, iterator.current gives us the current element at the iterator's position. Throwing exceptions. In Dart, throwing an exception is a way to signal that an error has occurred. When an exception is thrown, it interrupts the normal flow of code execution and can be caught by catch blocks for proper handling. In the code example, we define a main function in which we check if a given value is greater than 100. If it is, we throw an exception with a descriptive message. When this exception is thrown, the print statement will not be executed if the value is greater than 100, because the flow of execution will be interrupted and will move to the nearest enclosing catch block or cause the program to terminate if uncaught. This example illustrates how to throw an exception manually in Dart. Catching exceptions with try-catch. In Dart, we use try-catch blocks to handle exceptions that may occur during runtime. Within the try block, you place code that might throw an exception. The catch block is used to catch and handle the exception. Optionally, you can also use a finally block to execute code whether an exception is thrown or not. In the provided code, we attempt to divide 100 by 0 within the try block, which will throw an exception because division by 0 is not allowed. The catch block catches this exception, and a message is printed to the console. The finally block prints an additional message, demonstrating that it always executes, independently of whether an exception occurred or not. Finally clause. In Dart, a finally clause is used to execute code after a try block or an associated catch block has completed its execution, regardless of whether an exception was thrown or not. This is used for cleanup actions that should happen after the try and catch blocks, such as closing files or releasing resources. In the provided code, there is a try block where we anticipate that an exception might occur. If a specific exception is thrown, it is handled by the first catch block. If any other kind of exception is thrown, it's handled by the second catch block. Finally, the finally clause consists of code that will execute after the try and catch blocks have completed, regardless of whether an exception was thrown or not. This guarantees that the code inside the finally block will run no matter what happens in the try-catch blocks. Creating custom exceptions. In Dart, as in many programming languages, you can create custom exceptions to represent errors that are specific to your application's logic. By creating a custom class that implements the exception interface, you have the flexibility to add additional information and behavior relevant to the error. In the provided code, we've defined a class, myCustomException, that implements the exception interface. It contains a constructor that accepts a string message. The toString method is overridden to provide a custom string representation of the exception, which is helpful when printing the exception. This custom exception can now be thrown and caught, just like any built-in exceptions in Dart.